Hi, my name is Chloe Sharp. I'm a junior at the Mississippi School for Mathematics and Science, and I'm a high school student in the Micro Nanotechnology Student Scholars Program. We created a module to increase student proficiency in graphing and understanding the standard curve. Previously, we created a module to remotely teach fundamental statistical analysis skills, as well as how to use the graphing platform Data Classroom to accommodate the COVID-19 pandemic. After this module was completed by a group of Chem 1B students at Pasadena City College, we noticed a distinct lack in understanding of the standard curve, which was included in this module. This was concerning to us, especially considering how fundamental graphing and understanding the standard curve is in STEM fields. So we decided to create a separate module that specifically focused on teaching the standard curve to supplement the Data Classroom module. The standard curve module consists of 4 parts: teaching the standard curve, practicing creating a standard curve, applying the standard curve, and evaluating students' progress. To teach the standard curve, we made a definitions page that defined what a standard curve is and any terms that may be associated with a standard curve. We also chose outside resources from sources such as the Penn State Eberly College of Science, Khan Academy, and OpenStats that went more in depth on each term just to provide the students with more information if they needed it. This page also provided a textbook resource to the students so that they could reference additional information if needed. We also gave the students 5 informational videos that taught them how to graph standard curves in Excel and Data Classroom. 2 of these videos were created by a member of this project, and the 3 others were chosen from outside sources. To give the students practice creating standard curves and to evaluate their progress within the module, we gave them an assignment to complete. In this assignment, the students were given a data set that showed the relationship between the mass percent of table salt in a solution, which in our case was water, and density of that solution. They were then instructed to graph a standard curve in both Excel and Data Classroom in under 30 minutes. We instructed them to graph their standard curve in both platforms because we wanted to see how much information they absorbed from the original Data Classroom module, and we wanted to see how well they graphed in programs that they're less comfortable with. That way, we would know how to update the Data Classroom module if necessary. The students were also instructed to state somewhere in their submission what a standard curve is in their own words, what the equation of their curve is, what the correlation coefficient or R-square value is, and if the curve they graph fit the data set well based on their R-square value. We asked the students to explain all of this in their submission because we wanted to see how much they absorbed and retained from the module, and the module also included an answer key for this assignment that the instructor could either choose to use for grading their students' assignment or to give to their students after they've completed the assignment to check their work. After the students complete the graphing assignment, they move on to part 3 of the module, which is applying the standard curve. This part of the module consists of 2 labs that use the standard curve to interpret the data from those labs. The first lab is the Stolen Painting Mystery Lab. A famous painting was stolen from a museum last night, and the only piece of evidence left by the thief was a blue footprint found at the back entrance. After interviewing all the staff, 4 suspects were found to have a blue paint on their shoes that was similar to the one found at the back entrance. Scooby-Doo, Jake the dog from Adventure Time, Blue from Blue's Clues, and Snoopy. The paint found on each suspect, as well as the paint found at the crime scene, was sent out to a lab and tested to find the concentration and absorbance of each paint sample. This data was given to students who were then instructed to graph the concentration versus absorbance standard curves for each suspect and compare each to the concentration versus absorbance standard curves representing the paint sample found at the museum, which they were also instructed to graph. After the students finish this lab, they have to post a response in a discussion board where they state who they think the thief is and why. They also have to respond to 2 of their classmates discussing the similarities and differences between their findings. The second part of this lab, in part 3, is the Drink of Choice lab. In this lab, the students are given a procedure detailing a cereal dilution of a colored drink. The students then weighed the mass of each drink concentration at varying volumes and create a mass versus volume standard curve. They then mix a drink of unknown concentration, measure the mass and volume of that drink, and then use the standard curve to try to figure out the concentration of the unknown drink. We understand that some students may not have all of the materials necessary to complete this lab, so we provided a data set as well for those students. After the students completed this lab, a discussion was provided for them to answer questions about what their results mean. The discussion asked the students what their standard curves represent and if they thought their estimated concentration for the unknown concentration was accurate. Before the students start the module, they will be given a survey and graphing assessment in order to evaluate their skill level regarding the standard curve and other statistical analysis skills. After the students complete the module, they will then be given the same survey and a similar graphing assessment to evaluate their progress throughout the module and to assess if the module made them more proficient in graphing and understanding the standard curve. This module was created to teach undergraduate STEM students how to properly graph a standard curve in Excel and Data Classroom, as well as to teach them how to interpret standard curves and their components. While we don't have the data for this module yet, we are very optimistic that it will have great success in teaching students the fundamental of graphing and understanding of the standard curve. We are hoping that this module will be implemented in other STEM courses in the future to teach those students the basics of using the standard curve to represent a data set.